This is a short introduction to FreeStation and to the smart platform for real-time monitoring, early warning and analysis using low-cost open source sensors. So what is FreeStation? We know that ground-based monitoring infrastructure has been declining globally over the last decades, as we see in this diagram here of numbers of weather stations. And this is because of the cost of these in terms of maintenance, but also the fact that some of these data are being replaced by remote sensing data. And at the same time, we really do need these kinds of data more and more, and so it's unfortunate that this infrastructure is declining around the world. However, technical barriers to do-it-yourself data logging, do-it-yourself sensing, have fallen over the last decade in particular with the generation of low-cost microprocessors such as Arduino, Raspberry Pi, Internet of Things, connected devices, 3D printing and low-cost electronic components available on websites such as eBay. FreeStation project, which has been going for some 6 years now, is a set of designs for low cost, and that's around 3% of the commercial cost of most of these instruments, but robust, accurate, do-it-yourself environmental monitoring equipment, which is also open source, and the FreeStation Live stations are internet connected anywhere in the world. They're available for monitoring a range of variables from river stage through meteorological variables to soil moisture and a whole bunch of other things, including water quality and so on, cheaply, accurately and robustly. And because of the low cost, of course, they can be deployed at many sites instead of just one site, and really capture the geographical heterogeneity that exists out there in the landscape. These are designed to be built by geography students rather than engineers, so they can really be built and maintained by anyone with basic skills. And alongside a web platform, we therefore have a turnkey monitoring solution. You build the station, you plug in the battery, it connects to the internet, and you have a whole suite of analysis and graphical tools for analyzing the data. These sensors can also link with and provide data to some of our spatial models like Waterworld and EcoActuary, which are web-based spatial models to go beyond what's possible with monitoring. Here are some example stations. We have data loggers that are just a few instruments, smaller like this. This one does temperature, humidity, air pressure and river stage using a sonar, through to full weather stations. And we have stations that are usable where there are no telephony networks, no 3G, no 2G. We call those local stations. They write to SD cards, and then we have stations that write their data directly through the internet. We call those the live stations. We have more than 350 of these now operating in 16 countries in a variety of landscapes, and hosted by a variety of institutions, from farmers through to major research institutions, and they are sending in data to our servers every hour, measuring data every 10 minutes. The server side of this technology is as important as the sensor side of the technology, and this is the basis of the Internet of Things, that through the connection of these live sensors, you see a stage sensor here next to a leaky dam, you see a soil moisture sensor here that's looking at conservation agriculture versus traditional conventional tillage. These sensors connect directly into our smart system, and that system is a suite of online tools that allows FreeStation data streams to come in, and allows filtering and error removal, integration with other data sets such as the Environment Agency API, integration with global forecasting models so that we can look at the variables into the future over the next week, as well as looking at the history of these variables, and visualization of data, management of the devices themselves, download of raw data, and various analyses that are specific to particular variables and to particular areas of interest. So I'll tell you a little bit about a couple of those later. So we have smart river, smart soil, smart weather, smart river. The analyses are focused on analysing the effectiveness of inline storage, natural flood management such as retention ponds, leaky dams, beaver dams, etc. And we have devices in all of those settings. Smart soil is a turnkey solution for monitoring and assessing the effectiveness of soil storage of water under different forms of land management, such as conservation agriculture versus conventional tillage. And then smart weather is much more for characterizing meteorological risks, but also meteorological norms. How does it work? Well, first of all, you build a FreeStation according to the instructions that we provide, and buying the components from eBay, from the various sellers that are required. You plug in the battery, the FreeStation connects to our servers, registers itself, and starts to send data. You complete a web form with your station's unique identification that the server returns. And then, having filled in that form, you receive a unique URL that gives you access to a dashboard like this one here, where you see your data. This is stage versus Environment Agency rainfall for the nearest station, where you can manage your station, download the data, and do all sorts of analyses. The analyses are universal, so plotting variables from different stations together and comparing them, for example, or they may be specific to particular variables, so that if you have stage either side of a leaky dam, for example, then you can do specific analyses to understand the effectiveness of the leaky dam, the effectiveness of conservation agriculture or any other land management intervention if you have soil moisture sensors in the area that's intervened and in a counterfactual next door. So here's an example that I'll just take you through. This is one of our stations in South Essex. If we click here, which is the unique URL for this station, we can see the data over the last week. We're looking at temperature here and rainfall at this station. It's measured every 10 minutes, averaged every hour, written every day. We can go back and look at the last month. I took the station offline here, that's what you see there. We can look at the last year. Here we see the very hot period in July, 36.2 at this particular location. Or indeed we can look at the forecast. So this is from a global forecast model, and we can see here that we have the recent data and then the forecast data for the location of this station. It knows where it is, it pulls in the forecast, and we display that as well. There's a whole lot of analyses that you can do. We can compare different variables with each other. So for example, if we wanted to look at solar radiation, we can do so. This is solar radiation, and if we wanted to compare that with temperature, here is the comparison of the two, and we can do that over time, or we can do that as a scatter to indicate that clearly as solar radiation increases, then air temperature increases, but there is clearly noise there depending on cloud cover. There's a whole range of things that we can do in analyses, but we'll look at those in the next example. So here we have another station with its unique identifier. This is L93. This is in Spain's Hall, and here we have two stage gauges either side of a leaky dam. And so what we're going to do is to plot those against each other first. So we go to the first station. This is the rising limb after a rainfall event of stage, and we're going to hit the analyses button, and the first thing we're going to do is to plot this upstream station against the downstream station, which is L48. So we're going to do that, L48. And then since this is measuring distance from the sensor and we need distance from the base of the river, we are going to set subtract maxima there and hit submit. And what we see here is in blue the upstream stage, upstream of the leaky dam, in black the downstream stage, and we see of course that as the event occurs we get a build-up of water upstream. It's not a very strong event and it's quite a leaky dam, and that happens before we get that increase downstream and is sustained. We can do some analyses around that by going back here and then choosing one of our other analysis options, difference in stage change either side of the dam. So we will look at that one here, and again our downstream gauge is L48, so we'll type that in, hit submit. And then what this is doing is taking the two data streams from the two stations and it's saying, okay, what is the difference between them? And of course at the point of the rainfall event what we're seeing is a very positive value, an increase in height above the upstream of the dam is much higher than or a little bit higher, not a big event, than downstream of the dam, and then it normalizes afterwards. So there's a whole load of things that we can do in these analyses that calculate a variety of properties depending on what variable you are looking at, including mitigation of flood peaks. For example, if you know your river stage downstream or your river flow downstream. So how do you start? Well, the building instructions are at freestation.org, the installing instructions are at freestation.org. Switch them on, the data starts coming in. Go to the Smart website, complete the form that looks like this, putting in your FreeStation ID that you obtain from the station and how you would like your web interface to look in terms of what data is displayed, and then you will get your unique URL or embed code. Thank you very much for listening.